Okay, let's look at the homework 4.7, number 10. All right, and here's what we need to pay attention. The intensity of illumination is here, inversely proportional to the square of the distance from the source. All right, then you can see that here, the distance from P to the source on the left can be found by Pythagorean theorem. This is simply square root of d squared plus x squared. Right? The source, the distance to the source, light source on the right is going to be, so this is going to be 6 meter minus x, 6 minus x, and this is still d. So this is going to be square root of, let's see, there's no room, square root of d squared plus quantity 6 minus x squared. Right? So square of the distance, so we just have to take away the square root. So we know that I of x is going to be equal to, and we can also use the constant of proportionality is 1, so it's going to be just 1 times 1 over d squared plus x squared plus 1 over d squared plus quantity 6 minus x squared. Right, so that's how they got that. All right, then what we want to do for part B is that if d equals 3, then use the graphs of I of x and I prime of x to find the value of x that minimize the intensity. Right, so let's sketch the graph using Geogebra. So open up Geogebra. Right, so I of x would be, so I of x, right, so colon equals, to define the function, is 1 over, right, d squared. Actually, we have to define d first. I'm going to use something called a slider, and so that we can change these values later. So I'm going to call this d, and d is going to be between, say, 3 and 6. Right? You can use different numbers, but it's at least covers 3 and 6. Right? And then say apply. Right? So you have a slider. So then you can define the function using d. So d squared plus x squared, right? And plus 1 over d squared plus quantity 6 minus x, right? So put that in there, right? So the graph is there, but it's kind of hard to see, so I'm gonna just stretch the graph a bit so that it's a little easier to see, right? So I'll stretch it out. You can see that. Right, now you can see it pretty well here, so I'm gonna just bring it down a bit, and I can stretch even more. Whoa. Right, something like that. Right, so here's the graph, and if you want to find the derivative of that, and the derivative of the function is actually, we have to compute it. Let's see, actually this is sufficient, so maybe I'll just use the original function. All right, so here's the graph. Right, so let's look for the minimum value. So minimum value between 0 and 6, right? Then smallest value occurs right here, right? So this is at 3, so therefore answer is 3 right here, right, at x equals 3, right? But if you change it to d equals 6, right? You can see that if you change that to d equals 6, so I'm gonna use this slider. So d is currently 3, but if you change that to 6, all right, you can see that the between 0 and 6, smallest value is either at 0 or 6. So if you go back to that, right, it's going to be 0 or 6. So here's 0 or 6. All right. All right, then what happens is, maybe you can see it from the picture, right? So between 3 and 6, the point where minimum occurs changes. So if it's 3, definitely minimum occurs at 3. Then as it goes along, as d increases, you can see that here is the x equals 0, and here is x equals 6. Maybe you will find those values. Say I'm gonna say I0 is equal to I of 0. So you can see that that's I0 value. I of 3. So I'm gonna call it I3. So that will be I of I3 value. Enter. Right, so you can see that at 3 value is smaller for now, so I6 is equal to I of 6. All right, so you can see now that I at 3, I of 3 is going to give you the smallest value, but if I increase the d value, if you look at increase the d value, right? Now I3 is still the smallest, still the smallest, still the smallest. Now you can see that at this point it's already I of 0, and I of 6 is actually smaller than I of 3. Right? So it moves over to, minimum happens either x equals 0, x equals 6 instead of x equals 3. Right? So we want to know where exactly this transition happens. Right? So we're looking for basically where I of 0 and I of 3 are equal to each other. All right? So let's go back to the picture, the paper. All right, so let's look at the I of 0. So I of 0 is equal to, right, I of 0, so you plug in 0 here, so you're going to have, let's see, 1 over d squared, right, then plus 1 over, right, d squared, plus 6 squared is 36, right? Then you can take the common denominator. So this is going to be d to the 4th plus 36 d squared, and d squared plus 36 plus another d. So I'll put the 2 here. All right. And let's look at the I of 3. Right. It's very, very similar, but the 1 over d squared plus 3 squared would be 9. Then you have 1 over d squared plus 6 minus 3 is 3. Squared would be 9. Right? So you have the two of the same thing. So you have 2 times d squared plus 9. Right? So we want to find the value where these two values are exactly the same. So I'm going to set them equal to each other. So you have 2, actually I'm going to factor 2 from both sides, both terms. So 2 times d squared plus 18 over d to the 4th plus 36 d squared is equal to 2 over d squared plus 9. right? Divide through by 2, you can get the 2, and that's going to be 1, right? Then do the cross multiplication. You get, so multiply this guy by that guy, right? I'm going to get d to the 4th plus, right? 18 plus 9 is 27, so d squared. And 9 times 18, so let's see, 9 times 8 is 72, right? 1 times 9 is 9, so 162 is equal to, right, 1 times that is just a d to the 4th plus 36 d squared, right? And a d to the 4th on both sides, so you can cancel those out. Subtract that 27d squared, we can get the 162 is equal to 9d squared. Alright, so you can see that then divide through by 9, d squared is going to be 162 over 9. Right, then take the square root of both sides. D is equal to, square root of 9 is 3. And the square root of 162 would be what? 281.99. So it's going to be 9 square root of 2. Divide through by 3. Right? So D is 3 square root of 2. Right? It's really a plus or minus, but we're not going to consider the negative one since D is the distance. So you can see that is when D is 3 square root of 3, right? Got that. Right, that's it. I hope that this was clear.